Hello again, this is Mr. Petrie, and this time we are going to be converting mixed numbers to improper fractions. So before I get started, I need to think about what exactly I have to do. And I know that a mixed number is a number that has both a whole number and a fraction part. And an improper fraction, I know, this is what I'm looking for. I'm looking for a number that has, or a fraction that has a numerator that is greater than the denominator. Okay, and we're going to find that using 3 2/3 as an example. So what I've got right here is my strategy that I'm going to use first. I'm going to actually draw it out. So I've drawn out 3, 1, 2, 3, and I need, here we go, 2/3. Okay, so I've got 3 holes, 1, 2, 3, and 2/3 of a hole at the end. Okay, now I know one thing I can do is I can actually represent this whole using a fraction form. And I know that anytime I use a fraction where the numerator and the denominator are equal, that I have a whole. So I could use 2 halves, 3/3, 4/4, 5/5, 6/6, etc., etc. And in this case, I'm going to use thirds because I already have a denominator of 3 over here. So I'm actually going to split up my wholes into thirds. And as you can see, I've got 3/3 here and 3/3 here and 3/3 here. And then I've got 2/3 that are left over. And if I count all of these up, I will find that I have 11/3. Now, this method of drawing it out is great, but it can be problematic when you've got a large whole number here. So there is a way in which you can, do it without drawing everything out. And in order to do that, because we've got a lot of repeated multiplication or repeated addition happening here, 3/3 and 3/3 and 3/3 over and over and over again, we can actually multiply, and that is step 1. And I'm going to multiply my denominator by the whole number. And I know that I'm multiplying the denominator by the whole number because the numerator, like we said, 3/3 is going to be the same as the denominator. All right, so I've got 3 2/3. I want to find out what that equals. And if I do a little scratch work down below, I can go 3 times 3 is 9. And then the next step is I add what is remaining. I add the numerator, the existing numerator, to my product. So add the numerator to my product from number 1. All right, and that will work. So I've got 9, 3 plus times 3 is 9. I'm going to add this numerator, get 11, and I know that this is going to be my new numerator, and my denominator stays the same. Okay, so 2 ways we can do it. I can either draw it all out, separate it, and count them all up, or I can multiply my denominator by the whole number and then add the numerator. Okay, let's try that again. If I've got a number like 2.5, again, I can draw this out. I've got 2 and I've got a half. So 1, 2, and 1/2. All right, so there's my whole number. And again, if I divide this, I've got 2 halves, 2 halves, and 1/2. And if I add those up, 2 and 2 is 4, and 1 more makes 5. So I know that 2.5 is equal to 5 halves. Right? And same thing, if I just multiply right from the start, I would multiply 2.5. What does it equal? 2 times 2 is 4 plus the 1 extra. And this right here gives me my numerator. The denominator stays the same. And I've got a solution. So this works even with much larger numbers. So we'll do one more example with a large number just so you can see that it will work. So my third example, if I had like 102 and 5, 6. Okay. Again, I definitely don't want to draw out 102 squares. So I'm going to trust that this works. I'm going to multiply 6 by 102. Okay, and that gives me a total of 612, and then add on the remaining, which gives me a new numerator. All right, so I added that on, and my new numerator is 617 sixths. All right, and you can do that with any, to convert any mixed number into an improper fraction. Hope that helps.